go straight to our notes, but I am going to use the example that we didn't get to on Friday as our warm-up. So, notes open, warm-up. I want you guys to do the best you can on the following 4. Expressions, functions, relations. I guess they're all technically functions, yeah. Yeah, each 4 of them are functions, but they definitely look different. What was the last thing that we took notes on Friday? You should be writing this right below what? Domain, right? So we wrote a few things about domain. We were talking about section 1.4 functions. I'm trying to quickly dive into notes, but we can use the examples we didn't get to on Friday as our warm-up. And then if we get done early, we can go ahead and get the homework written down, maybe even dive in a little bit, but it depends on how today goes. Domain usually takes a little bit of time. Help me out really quickly. You guys are getting down the examples, which is good. But I just want to do a quick timeout. Timeout. Pencils and pens off the paper. Process. Domain. What kind of values are we looking for? So we're all on the same page? Okay, never mind. Take it back down. Let's see. I'll give you maybe 3 minutes. Let's go until 40. 10:40. To write down the examples and to try to get the best answer possible as to what you think the domain is of A and B and C and D. Yes, happy Monday. The weekend was a good one. How many of you guys took the SAT on Saturday? No one. Okay. Wait until later. Just in case you need a hint, letter A should be just a set of values. B, C, and D should be, well, for most of you, just inequalities. A should be a set of values. B, C, and D should be, for most of you, inequalities. One more minute for your best hypothesis. Best hypothesis possible. If it was a pop quiz, you wouldn't leave it blank, right? Hopefully. Just a few if you might. Blank if you can make a hypothesis. Alright, I want you guys in your groups compare answers real fast. not necessarily grading, you're just collaborating.
First one I got -2, -1.
I was looking at it talking about it, and I was like,
I'm reading that g of x cannot equal -5.
whoa, whoa, whoa.
Because you can have a domain for a 3. I mean, I'm not really sure about that.
0.
It's not also numbers.
It's just the x values.
I just found that
Just the x values. And then for b,
or I put x
x
so x equals h of x equals less than
equals
And then like, what's B?
yes.
5.
Yes. I put all the numbers 7 x.
Yes. So X is not equal. -5 because in the denominator, so you report them. Alright. The volume of the sphere, that was just the equation.
I don't think D
30 more seconds.
4 minus 3 is X.
This one.
I'm not sure
Well,
if
The last two.
square root, it can't be 0.
h of x is less than or equal to 1.
4 minus
There's no issue.
so X equals
There's no real restriction.
so X is any number anywhere there or equal to 0. We start with a negative.
Anything is 2, you have a negative, you can have a negative. Am I right?
It's less than 0. Because it's negative. Negative 3 times 8. Then you start going up, right? Like 2.
I just said 1.
Alright, what do you guys think?
Okay.
We haven't talked about interval notation yet this year, so I just use strict inequalities. Any questions or comments? Okay, how about reasons why? Letter A, how come -3, -1, 0, 2, 4? Why did I not use inequalities and say in between -3? Give me examples. Yeah, it includes all the rationals, not just the integers. Integers are just the whole numbers, and additionally, 1's not included and 3's not included. This is what we would call in math a discrete set of data, in the sense of it is only a collection of 5 points. That's it. So we only have 5 x values. That's it. There's nothing in between. Letter B. Why can x not equal -5? I can have a 0 in the denominator. I can't divide by 0. Can I have a 0 in the numerator? Can I have a 0 in both?
Or just.
No, but it does have a deeper meaning. Technically still undefined, but it still has a deeper meaning. Letter C. Why does R have to be greater than or equal to 0? Volume can't be a negative, and can a radius be negative? Just in closer application. Yeah, volume is like the broader scope. I can't make volume a negative, but radius can't be negative either. Now technically, would you have a sphere if R was equal to 0? No, so you could make an argument for R being greater than 0. I probably wouldn't necessarily mark that wrong. You could say if R is 0, it's not a sphere, or you could say it's a dimensionless sphere, I suppose, but then that wouldn't necessarily be a sphere. So you could say R is greater than 0. I just went ahead and said R can't be negative, and if R was 0, it would be a point. So there you go. D, how come X, why does...
You can take the negative square root.
Yeah, negatives under a square root are imaginary numbers, true? But what a lot of people get confused is why it's less than, well, first of all, why it's less than and not greater than, because you're used to positive numbers being greater than, but also why it's or equal to. How could you have set up an expression to solve for D? I think it was in our notes. Did we write it in our notes? Did we write expressions like inequalities? How do you start finding the domain for a square root of, how did we say it in the page before? Square root of f of x, is that what we called it? Yeah, what do we do with what's under the square root? What should you have done? Oh, it's right there, what should you have done? Is it better if you don't look at this as 4 minus 3x and you look at it as square root of box? And look on the page before. Instead of thinking of square root of f of x, you talk about square root of box. Whatever is under the square root. How do we set up an expression to solve? We take it and we do what to it? Set it greater than or equal to 0. Some of you weren't confident because you saw a less than or equal to, but it works. That's the process. So you take what's underneath the square root, and what do you do with it? Set it greater than or equal to 0. Now how would you solve that expression? I'm just putting the box to let you know whatever is under the square root, take it. That is the argument. That has to be positive or 0. So now how do I solve? Subtract the 4. I get negative 3x greater than or equal to negative 4. Now what? Divide by negative 3. See, it's a simple math expression. We just have to remember with inequalities, what happens when you multiply or divide by a negative number? Does that leave where we need it to go? Exactly where we need it to go, right? So trust the system, trust the process, trust the definition of the square root, how the argument must, in order to be a real answer, must be, oh, wrong way, must be positive or 0. Basically, it must be non-negative, okay? So then for number 2, maybe you guys need to go in your notes, and if that made sense to you, me drawing the box and being like, just take it, just take the argument and set it greater than or equal to 0. Do the same thing with denominator. Say whatever is in the denominator. Take the whole denominator, set it not equal to 0. Which won't be a big deal if it's something like, what was that, letter B? If it's something easy like that, most of you did that mental math. If you realize denominators can't be 0, most of you went ahead and then saw this expression and said, oh, he can't be 0, x can't be negative 5. But what if I gave you a little bit harder expression? And maybe it won't be hard for you. I don't know. But let's do one last example before we go off domain. Or go away from domain. We'll never really go off of domain. What if I was to give you one more? What if I was to give you, let's do h of x is equal to 3x all over x times the square root of 3 minus 2x. Okay, walk me through. You don't have to do this alone. You don't even have to do it alone in your groups. Walk me through. What would I do?
It's a denominator.
Okay, I heard greater than or equal to 0. What's going on there?
Take away the denominator.
Someone's seen that, right? So that's going to be one dilemma. We are going to have to take 3 minus 2x and set it greater than or equal to 0. However, what else do we need to consider?
Denominator, so x cannot equal 0.
Exactly. So I'm going to go ahead and think about the denominator as well. And x times the square root of 3 minus 2x cannot equal 0 either. Now, I know that 3 minus 2x is written in 2 places right now. We're going to have to resolve everything at the end and say, okay, put all the conditions together and figure out what the domain needs to be. But my question to you, first of all, I think you know how to solve that. 3 minus 2x greater than or equal to 0. Let's come to this one over here. How do we set or solve for x when it's in 2 different spots and I'm setting it not equal to 0? I guess you could plug in. That wouldn't be the procedure that I would hope that we would do eventually. Set, yes, I like it. Set what?
Set it equal to each other.
What equal? Not to each other. Does it help if I add one little thing? And some of you are like, oh yeah, I think those are supposed to be important, but usually we don't think about them. Does that make a difference? What do you do when you have factors, just two things multiplied, factors equal to 0. Oh, you know. You're just not thinking in the harder problem. What if you had something like this equal to 0? I know you know what to do.
Set equal to 0.
Set what equal to 0? Each factor, each parenthesis. There's multiplication. Set each one equal to 0. Now some of you are just gotten so used to saying -1 and 2, I just wrote it in order from left to right. You forgot what you do. You set each factor equal to 0. That's what you did in Algebra 1. Solve, right? So what are we going to do in a harder problem? Process is still the same. So what do we do? Set each, good. Now, I know it's a not equal to 0, that's okay. We're finding the zeros and saying you don't work. So just think of equal to 0 like not equal to 0. So we already have 1, x cannot be 0, that's true. What else can x not be? How are we going to solve? And I know if you get stuck. 2/3?
3.
That's better. But just in case, some people would get stuck. If you wouldn't, then remember you have those tutoring hours. Other people would definitely get stuck at the square root. How could you tell someone who's stuck there and doesn't even, their brain won't let them look in here without getting rid of that? How would you get rid of the square root? Good. But what's 0 squared? Good, so that goes away. So you were right, 3 minus 2x can't be 0. When you add the 2x, divide by 2, you're right, x cannot equal 3/2. What do we do with, okay, we have this piece, we have this piece. What's going on over here at this piece? How do we solve this guy? 3 minus 2x has to be greater than or equal to 0. Who's already solved it? What'd you get when you moved everything around? You could say 3/2 is greater than or equal to x. I think I would probably put x needs to be less than or equal to 3/2. Exactly. We need to resolve all the answers together now. And say x does need to be less than or equal to 3/2, but wait. What does this say over here? Can't be 0, first of all. So we have to say x is less than or equal to less than or equal to 3/2. But x cannot be 0 and x cannot be 3/2. Well, how do we just make that nice and neat? Just less than 3/2, right? Take away the or equals, because that's not allowed because of this condition. So take away the or equals. X is every number less than 3/2 excluding
0.
Now, I think you guys might have seen something called interval notation last year. It's possible. So I'm just going to show this as a little extra. Like another way of writing the answer would be a little bit more, a little bit neater, a little bit nicer, a little bit more professional, I suppose. You would say something to the effect of x is an element of negative infinity to 0, 0 to 3/2. But don't worry, this is what we call interval notation. It is an alternative to inequalities. If you want, you can write it down. Did you guys do interval notation with brackets and parentheses last year?
Minimal.
Okay. So don't worry, we're going to definitely cover it. This is not what you're expected to know right now. I'm just showing the little U, if you remember, stands for union. There's union and intersection. That's an or, that's an and, that's from geometry. The ifs, thens, and all that. Anyway, long story short, x is everything less than 3/2, but not 0. Do you guys see how this is like a big Mama Bahama problem that put all kinds of stuff together? Okay. Let's keep going. Range. Domain. Domain is so nice because I can tell you, if we had time, I could go into logarithms, I could go into trig, I can tell you, watch out for these functions. Boom, 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 boom. If you see one of these functions, this is for domain. If you see one of these functions, this is the problem, this is how you find the domain. We reviewed denominators and square root. That's all we've done so far. But I could do that with all the different possible functions whose domain is restricted. Range is a whole other beast. range is a whole other beast. I cannot give you a list of every single type of function and all the different ways of transforming functions and all the different ranges that are going to go with that function. I can't do it. There's too many transformations, there's too many combinations. For instance, the domain of x times e to the x. No square roots, no denominators, no logarithms, no trig. It's all real numbers. Domain, all real numbers, because it doesn't have any of the problems. Range, well, e to the x on its own. Range, the y's, how low does it go, how high does it go? Y is greater than 0 for e to the x alone, but then times x will extinct. Now it's all real numbers. Put the two together, what results? Range, my best advice. In Algebra 1, we were seeing super simple functions. I wasn't with you, but sorry, when I used to teach Algebra 1, the kids I was with. That was like Parsa's class. I'm pretty even calling it alpha. Before the merge, I guess I didn't have the anyway, long story short. The last time I taught Algebra 1, or even before. In Algebra 1, I tutored it too. It's pretty easy. You're just seeing lines and parabolas. And so we can say, hey, range, just make a table. Make a table and lines go on forever as long as they're diagonal or if they're vertical, so then the range is all real numbers. It goes through all heights. Parabolas. Is the range going to be all real numbers? How low does a parabola go when it's concave up?
The minimum.
The min. It goes to the min. It goes to that y value of the vertex. We can give you a formula for that. You can write it down. Or if the parabola is flipped, how high does the parabola go? To the max, the y value of the vertex. And I can say, okay, y is less than or equal to that max, or y is greater than or equal to that min. But the problem is, have you guys gone beyond lines and parabolas? Yeah. Last year you saw exponential functions, you saw logarithmic functions, we're going to review them. You saw maybe trig graphs, you used trig, I don't know if you saw trig graphs too much. You saw cubic functions, and quartic and quintic maybe, you saw different polynomials. You've seen a lot more. The ranges are different depending on. If I was to give you, ready? I want to give you a quick example before we even go into the notes. What if I was to give you the problem absolute value of x? I'll be super mean. This is like a calculus example of a function that they would see. Absolute value of x over x. It's okay to be graphing it. I'm not expecting you to pull this one off the top of your head unless you can break the absolute value down into a piecewise function where it's positive sometimes and negative others, which confuses many of you. And then simplify. And we'll do that when it's needed. We're not reviewing absolute value today. How do you find abs in your calculator? Math over. Or you can do the alpha and the second one, right? Yeah, alpha window. Abs is right there. Look at the graph. If I'm asking for, we'll look at domain. We'll review domain since we just talked about it. But then range. Okay, domain, I think I wrote a note in the notes. That sounds funny. I think I wrote a little note in addition to what I had up here. Did I say how left, how right? Yeah. Good. What would range's description be? If domain, horizontal values, how left, how right, what's range?
How high, how low.
How high, how low? How low, how high, right? How low does it go? How high does it go? So, looking at that graph, question, how left does it go? Forever. Negative infinity. It goes forever left. How right does it go? Forever. When you put the two pieces together, one goes forever left, one goes forever right, all of it is this function. Except, what are we going to have to be careful of because we see a problem? X cannot equal 0. I have a denominator, the denominator can't be 0. I don't have to do any solving, just long story short, x cannot be 0. So domain, I have a denominator, x can't equal 0. I didn't need the graph for that, but I let you guys look at the graph. My question for range, how low does it go?
-1.
-1. How high does it go?
+1.
Does it go anywhere besides those two values?
No.
So what would your range be?
-1.
No, not 2, 1. that's it. Is that weird? Oh, no. I think it's weird. I don't know if you guys think it's weird. It's not even an inequality. There's literally two ranges. Now, could you have made a table and plugged in -5, -4, -3, -2, -1, 0, 1, well, 0 would be bad. 1, 2, 3, 4, 5. Maybe you could have figured this out, but it would have been weird. We want to pull ourselves away from a table, but the dilemma is, right now, you can try. You can try checking values for the domain. You can try looking at the domain, seeing what possible x's are allowed, and you can try plugging in. Let's use the example I just gave you. G of x is equal to absolute value of x over x. You're seeing the graph because you went to your graphing calculator, but I'm saying what if I take that calculator away? Or I don't let you use it. You could have made a table. And you could have tried Algebra 1 stuff where it's like, I don't know, plug and chug stuff and see if you can figure it out. I'm just trying to prepare you for range in general for a function is very complicated because without a graph, functions get messy as soon as you start dividing by other functions, multiplying by other functions, adding by other functions, having like a trig piece with an exponential piece with a polynomial piece, you're like, I don't even know what to do with this. Or if you have like a square root of like a cubic function, you're like, but there's a square root, but there's a cubic, what am I supposed to do? So yes, you can try the good old-fashioned, wasn't this the Algebra 1 values? It was like -2, -1, 0, 1, 2. Isn't that what you guys always plugged in? Pretty close. Oh, that table got rough at the end. Ignore it. But you could try plugging in -2. That would be a positive 2 over -2, -1. Plugging in -1, that'd be a positive 1 over -1, that'd be -1. Plugging in 0, that doesn't work. Plugging in positive 1, 1 over 1 is, 2 over 2 is, and maybe you would have figured out those are the only numbers that are ever going to come out. So maybe you could have gotten it. I'm just trying to prepare you for. I cannot tell you. For range, a table always works. But what I can tell you is if you can get a picture, you can always look at the how low to how high. My warning is just what if you can't use a calculator? Does that make sense? Hence why we need to make sure that throughout this semester, especially, not really next semester, but this semester, that when new functions come, when parabolas come, when cubics come, when exponentials come, that you guys pay attention to the graphs, because sometimes that's the only way we'll be able to figure out range. Okay, so range, yes, I said check a table, but I did say, what if we can get those graphs down as much as is possible? Remember, a table is supposed to be the last result. But once again, range is hard. It's not as clear-cut or as simple, even though domains is simple. Basic, that sounds bad too. And formulaic, that sounds good. As domain. Range is not as formulaic as domain. But the graph hopefully is easy, looking at the how low to how high instead of how left to how right. But with more complicated functions, we gotta learn those parent functions. You guys ever hear that last year? Parent graphs, parent functions, the non-transform, like just x squared, not x minus 2 quantity squared plus 1 divided by 3.
Yeah.
X squared would be the parent function. So we have to learn how those parent functions move and behave so that we can apply that knowledge to harder ones. Okay. Now, hopefully we get to, you guys are honors, hopefully we get to get into a topic that's way easier and way nicer as long as you're careful and you don't work too fast and you put parentheses in whenever you needed them. Function notation, what am I talking about? How to name, that's good. How to name a function, true. What do we name a function when it's written in function notation? Do we say y equals? F of x, or g of x, or h of x, or usually not I, because that's the imaginary number, j of x, k of x, l of x, m of x. Hopefully we won't have that many. What does f of x, function of x, what does it mean? What part of that is the name? Y is a description of what kind of variable, I suppose. Isn't f the name? F of x, g of x, g of x, h of x. F is the name. We're saying, hey, this is f. And we're saying, not only is this f, but he is also a, this is what the, how do I put this? I'm not going to write it because it's just going to look confusing. This is what the parenthesis x means. F is just the name. The parenthesis x does not mean multiplication. That's one of the most common mistakes that's made. Hopefully not in honors, but possibly from time to time. This is not f times x. This is a special notation reserved for functions where we can get y by itself. You're very right. It is representative of y. But f is the name, and of x means that f is not only a function, but he's also a function of x. So the notation, I'll go ahead and write it here. When parenthesis x is written next to some sort of lowercase letter, in any sort of higher math, when parenthesis x is written next to any sort of letter, that always means of, not times. And it's literally representative of what is going to follow is a function that is only dependent on x. Do you guys remember the other day? It was Friday. And we talked about volume as a function of radius, right? And I wrote down volume, we technically hadn't reviewed function notation, as a function of radius. Does this make sense more of what I meant by this?
Yeah.
Volume is the y, equals, we could call him f, but even more specifically, when there's an f in parenthesis r, I'm saying here's volume and he is a function of solely dependent on radius, which is why we had to take that pi r squared h and say, uh-oh, this isn't true until I get the h, and I think we were able to plug in for h, it was like 4r, I think, if I remember right. As soon as we got here, we were able to say, yes, volume is now a function of radius. One step earlier, he was a function of radius and height. This is way more complicated to work with because now we have 3 variables. We're used to a simple 1 dependent, 1 independent. Okay, with that, I think I also introduced the idea of input and output the other day. Remember input? When we are thinking of just variables. We're putting in the x value, whatever he may be. He might be called r, he might be called t, he might be called, what's another common one? T is the most common one. We're putting in a value. So when we're putting in the input, we are just plugging in. And then to get the output, we're simplifying after we plug in. We're plugging in and then we're simplifying. Whenever we plug in the argument, we always need to put those parentheses. They're important in the beginning because they tell us of x, and they're important when we plug them in because, well, it's going to save you from a lot of poor little animals dying, let's just say. And then the equation that we're using is just the y equals f of x. This is just kind of setting up for the next page. So the input is the x that we put in, or whatever is inside these parentheses, whatever is inside. And I'm going to go ahead, for those of you that the box thing worked pretty well last time. Whatever is inside is the input. And we're putting it in with the parentheses intact. That way we don't mess up distributing negatives or squaring or anything like that. So here's an example. Technically the book, I think it has some examples where it actually has you use this kind of chart sort of thing. So I wanted to at least let you know what the chart represented, but right now we're just going to kind of just go for it in the sense of, if you notice, what is weird about the example that's given to you? What would you usually see here and that's not here? So what you might be given in the very beginning is f of x equals x squared minus 4x plus 7. What do you think they're trying to do with the gray boxes?
Where you plug it in.
This is where you plug in. This is where you figure out who to plug in and where do you plug him into. There, quantity squared, there, times -4, and then the +7 is just his own little deal. It's a plus constant at the end. So it's letting you know, yes, I know, you know that x is a variable, but you have to remember that it is also a place where an input is supposed to go. So, and without having to make the boxes, you could just put the parentheses and say, oh, I know, whoever's here needs to be copied here and there. Think like a computer program, if you were to put something here, it would be inputted there as well, because these are all equal, these are all equivalent. So as soon as you get down here and you write down f of -1, and you might wonder why I'm spending so much time on this, but it's because so many mistakes this year will come from people not doing correct function notation. Where is that -1 supposed to go?
Everything.
Parenthesis first, then a -1 quantity squared, right? Where else is he supposed to go? After the 4 in parentheses, and then the +7. What is the name of the game after we input the new argument? Simplify. So we can go ahead and say that we have a -1 squared is a +1. What's -4 times -1? +4. +7. What's the output going to be?
12.
12. What changes when you go to f of t? Yeah, now all the arguments need to change to t's, right? So instead of being box squared or x squared or -1 squared, who's going to be squared? T squared. Plug it in. If you want, you can put the parentheses. What's going to go next to the -4? T. It gets inputted, right? How hard is it to simplify that one? Not hard. So we just have t squared minus 4t plus 7. Sometimes function notation, the output is another equation, and that's totally fine. And sometimes function notation is another equation, and that's fine. Now here's where most mistakes happen. Letter C. To find f of x plus 1, who's now squared? Yeah. If you wouldn't bet your life that you know how to simplify this perfectly with no mistakes, you might want to check out the puppy rule up on the board. Or up above the board. Don't kill a puppy. What's going to go next to the -4? Then you have to simplify. How do you simplify x plus 1 quantity squared? FOIL. X plus 1 times x plus 1. Long story short, you get x squared plus 2x plus 1. What do you need to be careful of, and why I put parentheses for the next expression? -4x and?
Minus.
Subtraction is addition of the opposite. The -4 comes into both distribution. So -4x is a yes, but what's the next piece? There are 2 places mistakes would have happened if this was a quiz ring. I'm not saying on your paper necessarily, but in your class, for sure. Then we have to, name of the game, simplify, combine like terms, right? There's only 1x squared. There's a 2x minus 4x. There's a 1 minus 4 plus 7. Double check my mental math. Mental math is dangerous. Helpful, but dangerous. Okay. There is something at the end of homework that we're actually going to go over right at the beginning of class. Oh, piecewise function? Forgot about him. This is what I was talking about. We're going to take notes on 2 things tomorrow, piecewise functions and difference quotients. However, question. Difference quotient. Should you be able to use what we just did to figure out who this is? And then, shouldn't you be able to know who this is from what's given? And shouldn't you be able to put it in a big old fraction and try to simplify? Yes. I want you to do your best on getting all the way through, totally attempting homework This will challenge your function notation abilities. First thing tomorrow, we'll come in and talk about piecewise and difference quotient right before we grade the attempt you were able to do. So get all the way through homework. At the very end, we'll come piecewise and difference quotient. As soon as you guys have cracked that, bye guys. Challenge yourselves. Look at the example. Your honors. Be independent. Be resourceful. See what you can figure out. You guys rise to the challenge tonight.